Hello everybody, welcome into another lesson. So today we are going to start the few lessons on graphing trig functions. In today's lesson we will focus on graphing the sine and cosine functions since they have very similar graphs to each other. So here you have f of x equals the sine of x. Let's go through and graph this in real time. So that coefficient on the sine is what's called your amplitude. Really, the amplitude is the absolute value of that coefficient. The reason you take the absolute value is because you may have a negative coefficient. Well, in this case, your base coefficient for the original sine of x function is just 1, so your amplitude's 1. Now, the period of the sine function is 2 pi. So it completes a full cycle from 0 and then back to 0, going through all the positive and negative values in a period of 2 pi. When you graph these functions, it's custom to include 2 full periods. So we go from negative 2 pi to 0 and then from 0 to 2 pi. Now your domain of the sine function is just going to be the set of all real numbers. There's no value of x that would make this undefined. Now your range, so we've been doing mathematically finding values of sine functions, and your range is from negative 1 inclusive to 1 inclusive. It's never going to be less than negative 1, it's never going to be greater than positive 1. So it could be negative 1 up to positive 1 and any value in between. So let's graph this in real time. So the sine of 0 we know to be 0. What about the sine of pi over 2? That's just simply 1. Now what about the sine of pi? That's back to 0. What's the sine of 3 pi over 2? Well, that's going to be negative 1. Then the sine of 2 pi is 0. Alright, the sine of negative pi over 2 happens to be negative 1. The sine of negative pi is 0. The sine of negative 3 pi over 2 is positive 1. Then the sine of negative 2 pi is 0. So let's graph this. So your sine curve is going to work something like this. And then we go to the left branch of this here and connect the dots. And there you have it. There is your standard graph of f of x equals sine of x. This is also what's called an oscillating function because it'll go on infinitely no matter what value you put in for x. We just show from negative 2 pi to 2 pi, but in reality it goes on like this infinitely. That's why it's called an oscillating function. And then when we go to do the cosine function, you're going to find it's pretty much the same, only it's a little bit different, but it looks very similar. But why is the period 2 pi? So if you look, you go from 0 to positive 1, back to 0, down to negative 1, back to 0. If you were to input a number greater than 2 pi, well, when you reach 5 pi over 2, you'll be back to positive 1. So as you see, it completes the full period of the full range from 0 to 2 pi, and it does it again from negative 2 pi to 0. So we have 2 full periods. So this here demonstrates that your domain is all real numbers. Your range is from negative 1 inclusive to positive 1 inclusive, and it doesn't become less than negative 1 or greater than positive 1. So you have a nice oscillating curve here for the f of x equals the sine of x. And a big application of these are harmonic motion and studying ocean waves and all those type of things. You ever see ocean waves and things like that? Scientists always use your sine and cosine functions to measure those. Alright. So yes, you know what's coming next. That is going to be our cosine function. We'll show you what that looks like. not too much changes with the cosine function, which is kind of nice. It's relatively similar, but it does look a bit different. Alright. So let's graph the cosine function in real time. So f of x equals, this time, okay, I got the right color. F of x equals the cosine of x. Alright, so what's the cosine of 0? That's actually 1. What's the cosine of pi over 2? That's going to be 0. What's the cosine of pi? That's negative 1. Cosine of 3 pi over 2 is 0. And then the cosine of 2 pi is 1. Alright, the cosine of negative pi over 2 is 0. Cosine of negative pi is negative 1. Cosine of negative 3 pi over 2 is 0. And then the cosine of negative 2 pi is positive 1. So let's go ahead and graph this. So there is your f of x equals the cosine of x curve. As you see, it looks somewhat similar to sine of x, but it's a little bit different because of your values of x, which really give you different outputs of y. So just like with the sine function, your amplitude again is your coefficient. It's the absolute value of your coefficient on the cosine. In this case, your standard amplitude's 1. You still have a period of 2 pi. It completes a full period in 2 pi, and we're graphing 2 full periods. Your domain is also the set of all real numbers. Your range also is from negative 1 inclusive to positive 1 inclusive, and of course every value in between, but it'll never be less than negative 1 or greater than 1. So there's the standard graph of the cosine of x. All right. Let's talk about reflections here. So let's say f of x equals negative sine of x. F of x equals negative of the sine of x. Well, your coefficient on the sine of x is negative 1, so your amplitude would equal the absolute value of negative 1, which would still give you an amplitude of 1. Now, what does that mean? Your amplitude really dictates your range. So your range is still going to be from negative 1 inclusive to positive 1 inclusive. Your domain's still all real numbers. Your period is still 2 pi. So let's graph f of x equals negative sine of x. Well, at 0, it's still 0. Now, normally the sine of pi over 2 is 1, but we have a negative sign on there, so it would actually end up being negative 1. The sine of pi is 0. Normally the sine of negative 3 pi over 2 is negative 1, but that negative sign makes it actually positive 1. Then the sine of 2 pi is 0. Alright, now the sine of negative pi over 2 is normally negative 1, but that negative sign turns it into positive 1. And then you have the sine of negative pi is 0. Negative of 0 is still 0. Now, normally the sine of negative 3 pi over 2 is positive 1. If you negate that, you get a negative 1. Then the negative sign of negative 2 pi is 0. So let's go ahead and graph this. So what you see you have the graph of the original sine of x all reflected in the x-axis. So in this case, you have a reflection in the x-axis. Because you have that, and that's true with any function in general. If you have a negative coefficient in front of the function, that is a reflection in the x-axis. Now, what if I did this? So what if I decided to do this, the sine of negative x? You might be thinking that's a reflection in the y-axis, which in a sense you'd be right, but really what's true with the sine function? It's an odd function, right? So that means this would actually be the same thing as negative of the sine of x, which we just did. So that's how that would work if you had something like the sine of negative x. All right. I suppose we better do a reflection of the cosine function to show you what that's going to look like. Alright, so f of x is going to equal negative of the cosine of x. So we have a negative 1 as our coefficient for cosine of x, so the amplitude is the absolute value of negative 1, still being 1. The idea is to find your range. You're going to take that amplitude, multiply it by your normal range, you'll get your value. So if the amplitude was 2, your range would end up becoming from negative 2 to 2. But we'll get to that in a minute. But your period's still 2 pi. Your range is still, your domain is still the set of all real numbers. Your range is from negative 1 to 1. And this is still going to be a reflection in the x-axis. So what's normally the cosine of 0? That's 1, but with that negative sign, it's actually going to end up making it negative 1. Now, what's the cosine of pi over 2? That's 0. Negative of that's still 0. Cosine of pi is normally negative 1. If you negate that, you get positive 1. Cosine of 3 pi over 2 is 0. Whoops, why am I going down to negative 1? That doesn't work. Cosine of 2 pi is normally going to be positive 1, but it'll be negative 1 with the negative sign. Alright, cosine of negative pi over 2 is 0. Cosine of negative pi is normally negative 1. If you negate that, you actually get a positive 1. Cosine of negative 3 pi over 2 is 0. Cosine of negative 2 pi is normally going to be 1, but if you negate that, you'll get negative 1. So let's go ahead and draw the shape of this. So as you see, this is the graph of the normal cosine of x function, but simply reflected in the x-axis. That's all that really is. Alright, so there's some reflections. Now, let's deal with other things. Let me make sure I'm not erasing too much here. All right. What if I gave you something like f of x equals 2 times the sine of x? So f of x equals 2 times the sine of x. So all of a sudden we have a coefficient other than 1 on the sine of x. Well, for your amplitude, what you got to do is take the absolute value of that 2, which would give you an amplitude of 2. The amplitude does not affect your domain, but it does affect your range. The normal range of the sine function is from -1 to 1, both inclusive. That 2 changes your range from -2 inclusive to +2 inclusive. Your domain's still all real numbers. Your period is still 2 pi. So, alright, let's do sine of 0 is still 0. 2 times that is 0. Sine of pi over 2 is 1. Take that times 2, you actually get 2. Sine of pi is 0. Sine of 3 pi over 2 is -1 times 2 is actually -2. Sine of 2 pi is 0. Sine of negative pi over 2 is -1 times 2 is -2. Sine of negative pi is 0. Sine of -3 pi over 2 is +1 times 2 is 2. Sine of -2 pi is 0. So let's draw this. So what you have is a vertical stretch of 2. Just like with any other function out there, that coefficient either denotes a vertical stretch or shrink depending upon what your coefficient is. We have bigger waves, so that's what this is going to look like, and you see your range from -2 to 2. Let's do one with a shrink, and we'll do that on the cosine function. Okay, so let's make this one f of x equals half of the cosine of x. So f of x equals half of the cosine of x. Okay, so that's going to end up being your amplitude would be the absolute value of that 1/2, which would of course give you 1/2. Which that also affects your range. You take that 1/2, multiply it by your normal range, you'll end up getting a range from -1/2 inclusive to +1/2 inclusive. So your range is actually shrunk. Your domain hasn't changed. It's still all real numbers. You still have a period of 2 pi. Alright, so what's the cosine of 0? That's normally 1, but half of that is 1/2. What's the cosine of pi over 2? That's still 0. What's the cosine of pi? That's normally -1, but take half of that, you'll actually just end up getting -1/2. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is normally 1, but take half of that, you get half. Cosine of negative pi over 2 is 0. Cosine of negative pi is normally -1, but half of that's -1/2. Cosine of -3 pi over 2, that's going to end up being actually 0. Cosine of -2 pi is normally going to be 1. Take half of that, you get half. Alright, so let's... Whoops, that's tacky. Let's not do that, hey? And as you see, I have a thinner cosine wave. It tends to hug the x-axis more. So this is a vertical shrink. You actually have a vertical shrink by a factor of 2. So because the coefficient's 1/2, you have a vertical shrink by a factor of 2 because the range is half of what it normally is. And it tends to hug the x-axis more. Alright. Now it's time to talk about changing the period. That's also a very important thing to discuss here with graphing these functions. What happens when we let's see, 5, there's your negative pi. I just want to draw back in 4, 5, there's positive pi. Alright, perfect. So let's say in general you have the sine of bx. So inside, whether it's the sine or the cosine function, you have some coefficient on the x. That does affect your period. That totally affects your period. So what's going to happen? Your period is actually going to end up being, it's really 2 pi over b. Yes, the standard period's 2 pi, okay? But the b has up to this point been 1. That's been our coefficient on the x. So really, you would find your new period by taking the 2 pi and dividing it by b. Now your domain and range won't change in this case. You'll still have a domain of all real numbers, a range from -1 to 1, but your period's going to change. So let's go ahead and do one here where we have, let's say we have the sine of 2x. We're going to graph the sine of 2x. So what's our amplitude? The coefficient on the sine is 1. Absolute value of 1 is 1. So that means our range will still be from -1 to 1. Now we have the period is really going to be that 2 pi divided by that b of 2. So all of a sudden our period just became pi. We complete it in half the period. So that means we can change these points on our graph. Yes, we're still going to show 2 full periods, but it's about to change what they're labeled. It's going to look similar, but you're going to go from 0 to pi, and then from -pi to 0. So in between these points, you'll have 0, pi over 4, pi over 2, 3 pi over 4, then pi, and then you'll repeat it in the negative direction. Alright, so we go from -pi to pi. Well, if we put in x for 0, what happens? If we put in 0 for x, you still have the sine of 0. That much hasn't changed. Now, what if we put in pi over 4 for x? Well, 2 pi over 4 is pi over 2. That's going to give you 1 for your y value. The normal sine of pi over 4, of course, is the square root of 2 over 2. But you have 2 times pi over 4, which gives you the sine of pi over 2. So that's why we're labeling different points on the axis as opposed to the normal ones. If I put in pi over 2 for x, that actually turns into the sine of pi, which is 0. If I put in 3 pi over 4 for x, that turns into 3 pi over 2, which is actually -1. Then if I put in pi, that's the sine of 2 pi, which is 0. Now if I put in negative pi over 4, I'll get the sine of negative pi over 2, which is negative 1. If I put in negative pi over 2, I get the sine of negative pi, which is going to be 0. If I put in negative 3 pi over 4, I'll get the sine of negative 3 pi over 2, which is positive 1. If I put in negative pi, I get the sine of negative 2 pi, which is 0. So it looks pretty much like the standard graph of sine of x. And if you tried to graph this to 2 pi in this case, you would be graphing more than you need because we have 2 full periods here. It's just your critical points are labeled different coordinates because you complete a full period in pi as opposed to the full 2 pi. All right. As a matter of fact, this is going to change again because I'm about to do another period change. Let's say I take the cosine of 1/2 of x. So I'm taking the cosine of 1/2 of x. The coefficient on x is 1/2. Well, let's look at the amplitude. Coefficient on cosine is still 1. The absolute value of 1 is still 1. So our amplitude hasn't changed. That means our range stays the same, from -1 to +1. The domain's still all real numbers. That hasn't changed. However, the period's changed because of that coefficient on the x. You would take 2 pi and divide it by 1/2. You should actually get a period of 4 pi. So we're going to have a period, one period this time is 4 pi. So let's label all those points here. There's 2 pi, 4 pi. Here's 3 pi. Here's pi. Negative pi, -2 pi, -3 pi, and then -4 pi. So we have longer periods here. We go from -4 pi all the way to 4 pi, but one period is 4 pi, so this still shows 2 full periods. Alright, so if I put in 0 for x, well, I still get the cosine of 0, which would give me 1. Now, if I put in pi, I'll end up getting pi over 2. The cosine of pi over 2 is 0. If I put in 2 pi for x, I'll just get the cosine of pi, which is -1. If I put in 3 pi for x, I'll get the cosine of 3 pi over 2, which is 0. And if I put in 4 pi, I'll get the cosine of 2 pi, which is 1. If I put in negative pi, I'll end up getting the cosine of negative pi over 2, which is 0. If I put in -2 pi, I'll end up getting the cosine of negative pi, which is -1. If I put in -3 pi, I'll end up getting the cosine of -3 pi over 2, which is 0. Then if I put in -4 pi, I'll get the cosine of -2 pi, which is +1. So there's going to be my graph. As you see, my range hasn't changed, but my periods have. I go from -4 pi to 4 pi this time. Alright, so we've done some change in period. Now we need to do some vertical and horizontal shifts. We'll start with some vertical shifts first. So let me label the axis again here. Two, 2, negative, there's positive pi over 2, positive pi, positive 3 pi over 2, and then positive 2 pi. All right. So let's see here. Why don't we do the sine of x plus 3? So actually, it's probably best if I do this, because that could look like the sine of the quantity of x plus 3. We don't want to do that. Let's say we have 3 plus the sine of x. That's probably the better way to write this. Well, let's look at the amplitude of the sine. Your coefficient on sine itself is 1, so that gives me an amplitude of 1. The period, well, my coefficient on x is 1, so 2 pi divided by 1 is 2 pi. We're still back to the normal 2 pi period. Well, alright, so my domain is still going to be the set of all real numbers. That hasn't changed, but my range has changed. So what we have here, you have a vertical shift up 3 units. So this is a vertical shift up 3 from the original sine of x. So what is your normal range of sine of x? Your normal range is from -1 to 1. If you add 3 to -1, you get positive 2. And then if you add 3 to positive 1, you get 4. So in actuality, what's happened is your range now becomes from positive 2 inclusive to 4 inclusive, and every value in between. So a vertical shift does affect your range. So what's the sine of 0? The sine of 0 is 0, but you got to add 3 to that, so you'll be all the way up at 3. Now what's the sine of pi over 2? That's normally 1, but you add 3 to that, you'll actually end up at 4. Alright, so what about the sine of pi? That's normally 0, but you got to add 3, you'll end up at 0. What's the sine of 3 pi over 2? That's normally -1. Add 3 to that, you'll actually be down to 2. The sine of 2 pi is 0. Add 3, you'll be at 3. Now the sine of -pi over 2 is normally -1, plus 3 would actually give you 2. And then, let's see, the sine of -pi is normally 0, but you add 3 to that, you'll get 3. The sine of -3 pi over 2 is normally +1. Add 3 to that, you'll actually end up at 4. And then the sine of -2 pi is normally 0. Add 3 to that, you get 3. So here's going to be your graph with a vertical shift up 3. So there is the graph of 3 plus sine of x. Everything, like your domain has stayed the same, your period's still the same, your amplitude's the same, but you vertically shifted everything up 3, so that means your range becomes from 2 to 4. So there's everything vertically shifted up 3. All right. Let's do another vertical shift, but this time let's do -3 plus the cosine of x. So we're going to do -3 plus the cosine of x. Alright, so that denotes the original cosine function with a vertical shift down 3. we're actually going to go down 3 this time. Now, what is the normal range of the cosine function? That's normally -1 to 1, right? So if you take -3 plus -1, you'll get a range of -4. If you take -3 plus +1, you would end up getting -2. So your range just changed to -4 inclusive to -2 inclusive. Alright. Well, if you look at your amplitude, it's still 1, since the coefficient on cosine is still 1. Your period's still 2 pi, since the coefficient on x is 1, and your domain is all real numbers. So let's go ahead and graph this. What is the cosine of 0 normally? It's 1. Add -3 to that, you end up getting -2. Alright, so now what is the cosine of pi over 2 normally? That's 0, but if you add -3 to that, you'll end up getting -3. What's the cosine of pi? That's normally -1. Add -3 to that, you'll get -4. What's the cosine of 3 pi over 2? That's 0. Add -3 to that, you'll actually get -3. Then the cosine of 2 pi is +1. Add -3 to that, you'll get 2. Alright, cosine of -pi over 2 is normally going to be 0. Add -3 to that, you'll end up getting -3. Cosine of -pi is normally -1. Add -3 to that, you'll get -4. Cosine of -3 pi over 2 is normally 0. Add -3 to that, you'll get -3. Cosine of -2 pi is normally going to be +1. Add -3 to that, you'll get -2. So let's go ahead and graph this. And there is your graph of -3 plus cosine of x. So this is the normal cosine of x function shifted downward 3 units, thus affecting your range. Alright, let's also talk about horizontal shifts of functions. So let's see, f of x equals the sine of x plus pi over 2. So f of x equals the sine of x plus pi over 2. Alright, so much like in other functions, if you have inside the parentheses x plus or minus something, you're going to have a horizontal shift. Set x plus 2 equal to 0, you would get x plus pi over 2 equals 0, you get x equals -pi over 2. So you have a horizontal shift left pi over 2 units. Now, your amplitude's still 1 because the coefficient on sine is 1. Your period is still 2 pi because the coefficient on x is going to be 1. Now, let's see. Your domain's still all real numbers. Your range actually hasn't changed because you don't have any vertical shifts or any other number on the x to affect your range, like a coefficient on it. So your range is still going to be from -1 to 1. You just have that horizontal shift left 2 units. So, good place to start. What is put in 0, that would actually give you the sine of pi over 2 right away, which would give you +1. Now, if you put in pi over 2, that's actually going to give you the sine of pi, which is going to be 0. If you put in pi, that would give you the sine of 3 pi over 2, which is negative 1. If you put in 3 pi over 2, that would give you the sine of 2 pi, which is 0. If you put in 2 pi, that would give you, well, that's 2 pi plus pi over 2, which would just be back to pi over 2. That would give you 1. Now, if I put in negative pi over 2, that gives me the sine of 0, which is 0. If I put in negative pi, I would get the sine of negative pi over 2, which would give me negative 1. If I put in negative 3 pi over 2, that would give me the sine of negative pi, which is 0. Then if I put in negative 2 pi, that would give me the sine of negative 3 pi over 2, which is positive 1. So something very interesting takes place here. So yes, this is technically the graph of the sine of x plus pi over 2, but it actually looks more like a cosine, doesn't it? This actually looks more like the graph of f of x equals cosine of x than it does a sine function. In fact, yes, these are properties that we've talked about before with periodic functions. So you can essentially think of this as the cosine of x, essentially, but pretty cool how that works. And yes, you know I have to do a shift with the cosine. And then we're going to do 2 more total where we're going to throw everything at you for 1. Alright. I'll keep it simple here. F of x equals the cosine of x minus pi over 2. So we're going to do f of x equals the cosine of x minus pi over 2. Alright, well your amplitude is still 1 because of the coefficient on cosine. Your coefficient on x itself is still 1, so your period's still 2 pi. Your domain's still all real numbers. You don't have any vertical shifts or other coefficients on x, so your range is still negative 1 to 1. But you do have a quantity in the parentheses. That x minus pi over 2, set that equal to 0, you'll get x equals positive pi over 2. So this time you have a horizontal shift right pi over 2 units. So let's see what happens here. If I put in 0 for x, I'll get the cosine of negative pi over 2, which is actually 0. If I put in pi over 2, I'll end up getting the cosine of 0, which is actually 1. If I put in pi, I'll get the cosine of positive pi over 2, which is 0. If I put in 3 pi over 2, I'll end up getting the cosine of pi, which is negative 1. If I put in 2 pi, I'll get the cosine of 3 pi over 2, which is 0. Alright, if I put in negative pi over 2, I'll end up getting the cosine of negative pi, which is negative 1. If I put in negative pi, I'll get the cosine of negative 3 pi over 2, which is 0. If I put in negative 3 pi over 2, I'll get the cosine of negative 2 pi, which is actually 1. If I put in negative 2 pi, I'll end up getting the cosine of negative 5 pi over 2, which is the same as the positive cosine of pi over 2, that's 0. So let's go ahead and graph this. So yes, this is technically the graph of cosine of x minus pi over 2, but this looks very much like just the graph of f of x equals sine of x. So very interesting how these horizontal shifts can make the graph look like the other function. I got 2 more graphs for today, then we're done with the lesson. Alright, we're going to throw everything at you for these next couple. Yes, you got it. Negative pi over 2, pi over 2 pi, 6, 7. Alright, there's the 3 pi over 2. Actually, that doesn't do any good because the period's going to change in this too. Alright. So, let's say I'm going to give you f of x equals negative 3 minus 3 times the sine of 2x minus pi. We have a lot going on here. We sure do have a lot going on, don't we? Alright, so we're definitely graphing a sine function. Well, let's start with your amplitude. You have a negative 3 on your, so you have a negative 3 on your sine. So that coefficient's negative 3, so the amplitude's going to be the absolute value of negative 3, which would just be 3. So tentatively, your range is going to be from negative 3 to 3. But this is going to change when we account for the shifts. Alright, well, here's the thing now. You have 2x minus pi. If you want to figure out your shift, so you have a, this is definitely going to be a horizontal shift to the right because it's 2x minus pi. So take that 2x minus pi, set it equal to 0, well, you would get 2x equals pi. That would give you x equals pi over 2. So you have a horizontal shift right pi over 2, don't you? So we've established we have a horizontal shift right pi over 2 units. Okay. So what else is going on? Because we're comparing this to the normal sine of x. You have here then your period. We can talk about your period. The coefficient on x is 2, so the period is going to be that 2 pi divided by 2, which would just give you a period of pi. So your period just became pi. Alright. Now, you also have a shift downward of negative 3. You have a vertical shift down of negative 3. So vertical shift down 3. Well, that amplitude being 3, it made your original range negative 3 to 3. However, you're shifting down another 3 units. So you need to subtract 3 from each of these numbers of the range. If I subtract 3 from negative 3, I'll end up getting negative 6. If I take negative 3 plus 3, I'll end up getting 0. So my real range just became from negative 6 to 0. Okay, and then I have a negative coefficient on the sine, so we also have a reflection in the x-axis. So this is going to be all shapes of distorted. Alright, so now we've identified the period to be pi. So let me label these points. We have pi. Here's pi over 2. In between that, you have 3 pi over 4. Then you have between 0 and pi over 2, you have pi over 4. Alright, so 0, pi over 4, pi over 2, 3 pi over 4, pi. So we're going to repeat this going in the negative direction. 3, 4, 5. So there's negative pi over 2. Negative 3 pi over 4. And then negative pi. Alright. So there's our points. Let's go ahead now and start labeling all this. So let's say I put in 0 for my x. That would give me the sign of negative pi. That's still 0. Negative 3 times 0 is 0. Negative 3 minus 0 is negative 3. Alright, now let's say I put in pi over 4 for x. What's 2 times pi over 4? Well, that's just pi over 2. Minus pi actually gives me negative pi over 2. Okay, so what is the sign of negative pi over 2? That's negative 1, but if you take that times negative 3, you actually get positive 3. Then negative 3 plus positive 3 is going to be 0. Alright, and then if I put in pi over 2, that gives me the sign of pi minus pi. That's the sign of 0, which is 0. Negative 3 plus 0 is going to end up being negative 3. Alright, and then if I put in 3 pi over 4, what's that going to be? That's going to end up being 3 pi over 2 minus pi. Yes, 3 pi over 2 minus pi is actually going to end up being pi over 2. What's the sign of pi over 2? That's normally 1 times negative 3 is negative 3 plus negative 3 is actually negative 6. 6. And then if I put in pi, I'll get the sign of 2 pi minus pi, which is just the sign of pi. That's 0 minus 3 is negative 3. What a mess, huh? And then if I put in negative pi over 4, that gives me the sign of negative pi over 2 minus pi. That gives me the sign of negative 3 pi over 2. What is the sign of negative 3 pi over 2? That's normally going to be 1. But then I take negative 3 times that. I get negative 3 minus 3. I'll end up getting negative 6. Now let me take negative pi over 2. That would normally give me the sign of negative pi minus pi. That's the sign of negative 2 pi. That's 0. Then minus 3 is negative 3. Alright, negative 3 pi over 4. That's normally going to give me the sign of negative 3 pi over 2. Minus pi, that'd be negative 5 pi over 2, which is the same as negative pi over 2. So that would end up giving me negative 1 normally, times negative 3 is positive 3, minus 3 is 0. I'll actually end up at 0 here. Then if I take negative pi, so negative 2 pi minus pi, that's negative 3 pi, which would put me back to negative pi, that's 0. Minus 3 is negative 3. That's a little bit of a doozy, ain't it? So there is the graph of this function here, shifted from the normal sine of x with an amplitude of 3 with a period of pi, domain of all real numbers. Your range became -6 to 0, and your graph reflects that range very well. You have a horizontal shift right pi over 2 units, a vertical shift down 3, and a reflection in the x-axis. So yeah, what a mess, huh? That was definitely a mess. Alright. And we're going to do just one more. This time we're going to mess around with the cosine function. Alright. Okay, so this time we have 2 minus, you know what? I know what I wanted to do there. 2 minus 2 times the cosine. There we go. So we have 2 minus 2 times the cosine of 2x minus pi. Well, let's start with the amplitude. You have a -2 coefficient on the cosine. So the amplitude is the absolute value of -2, which would just be +2. So there's your amplitude. And this is going to preliminarily affect your range from -1 to 1 to become -2 to 2. So always start with that. And then, what do you see? You have a vertical shift up 2 units. So let's go ahead and document that. Which is going to affect your range one more time. If you add 2 to that, you'll end up getting from 0 to 4. So your range is going to become from 0 inclusive to 4 inclusive. Okay? Now, we have a reflection in the x-axis because we have a negative coefficient on the cosine. Alright, what else do we have? So, we can determine the period to be, if we take that 2 pi, divide by that coefficient on the x of 2, so the period is 2 pi over 2, you end up having another period of pi. So let me go ahead and label these points on the axis. There's pi over 2. There's 3 pi over 4. I'm going to make one change though. We're going to do 2x plus pi this time. Alright, here's pi over 4. Negative pi over 4. Negative pi over 2. Negative 3 pi over 4. Then there's negative pi. Alright, so there's going to be 2 full periods from negative pi to pi. So the only thing we haven't dealt with yet is the horizontal shift. If you take that 2x plus pi, set it equal to 0, you end up getting that 2x equals negative pi, which would give you that x equals negative pi over 2. So we have a horizontal shift left pi over 2 units this time. All right. So we have 2 minus 2 times the cosine of 2x plus pi. This is going to be a shift from this is going to change the original cosine of x function by a vertical shift up of 2 units, a reflection in the x-axis, a horizontal shift left pi over 2 units, with the range being from 0 to 4, your domain still all real numbers, and your period being pi. So having said all that, let's go ahead and graph this. What better place to start than 0? If we put in 0 for x, you get the cosine of pi, which is normally -1, but take that times -2, you get +2 plus 2 is 4. So see, 1, 2, 3, 4. All right. Now, if we put in pi over 4, that's going to end up giving you what? That ends up giving you pi over 2 plus pi, that's 3 pi over 2. The cosine of 3 pi over 2 is 0, plus 2 gives you 2. Now how about pi over 2? That's going to end up giving you the cosine of pi plus pi, that's 2 pi, which is +1 times -2. That's -2 plus 2 is 0. Alright, now 3 pi over 4. So if you put that in, you'll get 3 pi over 2 plus pi. That would give you the cosine of 5 pi over 2, which is the same as the cosine of pi over 2, which is normally +1, times -2 is -2 plus 2 is going... Wait a minute. Never mind. Cosine of pi over 2 is 0. So 0 plus 2 is 2. I don't know what I was thinking there. I thought of the sine for a minute. It's easy to mix that up. If I put in 2 pi, I'll get the cosine of 3 pi, which is the same as... Or pi would give me 2 pi plus pi, that's 3 pi. 3 pi is the same as 1 pi, so cosine of pi is normally -1 times -2 is +2 plus 2 is 4. And then let's put in -pi over 4. So -pi over 4 would give me -pi over 2 plus pi. That would give me the cosine of pi over 2, which is 0, plus 2 is 2. If I put in -pi over 2, I'll end up getting -pi plus pi, that's 0. Cosine of 0 is 1 times -2 is -2 plus 2 is going to be 0. Alright, let's put in -3 pi over 4. That would end up giving me -3 pi over 2 plus pi. That would give me the cosine of -pi over 2, which is 0, plus 2 is 2. Then if I put in -pi, so that would give me the cosine of -2 pi plus pi. That's the cosine of -pi, which is -1 times -2 is +2 plus 2 is 4. So here is going to lie my graph. So that barely looks like it was even reflected because of all the shifts going on. But yes, here's the graph of this function with all the changes from the original cosine of x. So that's it for graphing sine and cosine functions. The next lesson we're going to focus on graphing their reciprocals, which will be the secant and cosecant functions. So I hope everyone has a great day. Take care.